Hi there, I'm Ryan, an mlpack maintainer. In this tutorial video, I'm going to demonstrate how you can set up VSCode to develop and contribute to mlpack. If you prefer a simpler approach via the command line, like I do, check out the other video that discusses setting up a development environment from the command line. Okay, let's dig in. Okay, so I have here a clean VSCode session. So I haven't set up mlpack yet. That's what I'll do in just a second. But I have installed the dependencies of mlpack already on this system, following the build guide. So once I have done that, then the first thing I need to do is clone the mlpack GitHub repository. So in VSCode, I can do that by hitting Control-Shift-P to get to the commands. And then I can search for the git command, and I will git clone. I will clone from GitHub, because that's where mlpack's repository is. I will clone mlpack. So that'll take just a second. But when it's done, we can open it up, and we can see all of the things that we have in the mlpack repository. So the mlpack repository has a handful of directories. There are two that are really important if we're developing. One is doc. This has all the documentation for all the different parts of the library. And then one is source. This actually has the source code. So we just taking a look around, under the source mlpack directory, we have 4 different directories. Bindings, which I'm not going to talk about in this video. Core, this is the core of the library, so this is like things that aren't exactly machine learning algorithms, but they are useful inside of machine learning algorithms and also on their own. So things like distance metrics, probability distributions, math utilities, and I can click open some of these. So you see we have like a Gaussian distribution, things along these lines, kernel functions, so on and so forth. The actual machine learning parts are stored in the methods directory. So there are lots of directories here because mlpack implements quite a bit. Each one of these has one machine learning algorithm, or maybe a couple if things are very close to each other. So as one example, we have, say, mean shift clustering is here. There's a header file. Let me make my console get a little smaller here. We don't need that right now. So each file is documented pretty heavily, in addition to the documentation that we make available on the website, so that as a developer, if you're developing mlpack, you can say, oh, okay, mean shift has a constructor. That constructor has 3 parameters. We know what each of these parameters are. They're each well documented. And then we have a cluster method. So that cluster method here, it just takes some data, and then it takes a centroids object, and the centroids matrix will be filled with the centroids, and so on and so forth. So typically mlpack classes are kind of made in this way, where there's a constructor where you sort of set the configuration of the algorithm, and then there's maybe a method that actually does it. So like here it's cluster. If I go into something like random forest, the random forest class, it has constructors that also will train the random forest too. So there are a bunch of parameters to the random forest, and so on and so forth. The other directory I want to call attention to, so this is a methods directory, and of course there's not time in this video to go through everything there. Another thing is the tests. There are lots and lots and lots of tests inside of mlpack. You just keep scrolling all day long here. This is because it's really important to test machine learning code, make sure it works correctly. So, for instance, the random forest test, there are a handful of tests in this file. We use the catch unit testing framework. So that lets us say, oh, here's a test case. This test case is called bootstrap weights test. In fact, let me scroll down and look at this one. This one's called empty classify test. And the goal is make sure that an empty forest can't predict. So like if we create a random forest object, but we don't give it any data, it shouldn't be able to predict anything. And we'll put this test into the random forest test suite. So this is how all of the tests in mlpack are written. So now let's talk about how we can actually build the library. So with VSCode, VSCode has a CMake plugin, which I'm not going to click on yet, but that does all the configuration for us. However, I want to specify a couple special things about how we are going to do the configuration. So I'm going to create a new file, .vscode/settings.json. Okay. And inside of this file, I'm going to store the configuration for the way that we want our local build to work. So first, I'm going to set the build test variable to on, and I'm going to set the build CLI executables variable to off. And the meaning of this is, by default, mlpack doesn't build tests. This is because the tests take a long time to build, and there are a lot of them, as you saw. So if you're just a user installing mlpack, it doesn't make any sense to build the test. You don't need to do that. We'll do that as developers. But in this video, we're developing, so we want to turn the tests on. The other one is, by default, mlpack will build some command line programs to do machine learning tasks. That's nice and all, but in our case for this video, it's just going to slow us down because we're not actually going to use those. So we're going to set that to off. Okay, so now that this file exists, I can go over to the CMake tab here, and I can delete the cache that it auto-configured and reconfigure it. And sometimes it seems like I have to do this twice. But when I do, now I can see in the project outline, I have mlpack test. So I'm going to right click on that, and I'm going to build it. So now we'll get the output here that shows us that the library is building. However, this process, as I mentioned, takes quite a while. So I'm not going to sit here and talk through the whole thing, but you will get output as it goes. So I'm just going to skip to the end when everything is built. Okay, so that took a little while, but you can see the build is completed now, and in my case it took about 5.5 minutes, so that could be more or less depending on your system, how many cores it has, these kinds of things. Now that it's built, I can hit the play button down here to actually run the tests. Now in this case, I'm actually going to hit Control-C here and cancel running these tests because, as I showed you before, there are tons and tons and tons of tests in mlpack, and I don't want to run them all because, as you can guess, it takes a long time. So it's great to have those tests, but it sure would be great if we could run only a couple of tests at a time. And it turns out we can. So if I go back to my tests in source mlpack tests, let's open up the random forest test. Okay, make this a little bit smaller. Here's a test case. It's called extra trees accuracy test. So this is for the extra trees algorithm, and it's in the random forest test suite. So we can run mlpack test random forest test. And this will run all of the tests in the random forest test suite. So you can see we ran 15 test cases. And in fact, we could even run an individual test by itself if we wanted to focus on it. Extra trees accuracy test. And look, we have success. Okay, cool. So that's how you run a test. Now, what does it look like when a test actually fails? So let's go ahead and modify this test. So this test, let's look at what it does. It loads the iris data set to this data set here. It adds some noise to the data set, and then it trains the random forest, although this variant of random forest is called extra trees. So then we compute the accuracy. So what if we just required that the accuracy was greater than 99%? Let's see if this fails. So now that I made this change, I can hit build, and the test will be built. Now this time it'll take a little bit less time, a lot less time, because all we need to recompile is the random forest test. We don't actually need to compile the entire library and test files and everything like that from scratch. So CMake is smart enough to not do all of that work, but only do the work that's necessary. So you can see, yeah, we're only building random forest test here. Okay, and now that that's done, I'm going to switch back over to the terminal here and just hit up and run this test again. And so now you can see it fails. Here, I'll make it a little bigger. Now it fails because the accuracy that we got is only 93%, and we upped the tolerance. We said it needs to be greater than 99% as opposed to 85%, which is what it was before. So this is what it looks like when your tests fail. When you write tests or when you see something like this, it means something is wrong in the output. So let's go ahead and revert that change back to 85%. That was a reasonable percentage. Now let's actually add something to the library. So I'm going to add something to the random forest. Okay, so we have the classify method. I'm going to add a new method to the random forest. And this method is not a very useful method, but again, just for the sake of demonstration, return true if the number of trees is precisely 127 or 129. Why is this a function anyone wants? Well, nobody wants this function. Please don't open a pull request with this function. Just for the sake of demonstration, bool is number of trees magical. It's a const function. Actually, we should also document here that 127 and 129 are well-known magical numbers. They're actually not. Well, at least not to my knowledge. Okay, so that's our function in the header file. Now we need to actually add an implementation in the impl file. So the impl file has a lot of code in it already. It has all the other functions and the implementations of them. Now, random forest is a class that has 5 different template parameters. That means that when we write these functions, we have to, give the whole signature of the function. That's a lot. So I'm just going to copy paste, put the new function at the bottom of the file, and it returns a bool, not a double. And it's called, hang on, what did I call it? Go back to this file. Is number of trees magical? Is number of trees magical? Const. Okay, and so we'll just say if trees.size is 127 or if trees.size is 129, return true. Otherwise, return false. Okay, so there's our implementation. It's not too hard. Next, I want to talk about documentation. We have to document this in the user-facing documentation, otherwise users won't know about it. So if I go into doc/user/methods/random forest, I can find the random forest documentation. And so let me scroll to the top here. That's the documentation, and you can go to the website and see the rendered version of this. This is just the source of it. We have a handful of sections. We got the constructors, we have the methods to train, the methods to classify, and then we have other functionality. This new method, it sounds like it should be other functionality. It doesn't fit into any of these other areas. So let's scroll down to the other functionality section. And we can see each of the bits of the other functionality are individual bullet points. So we can just add another bullet point. So this one can say rf.is num trees magical. Is that what we called it? Let me double check. Random forest is number of trees magical. Number of trees magical will return a bool that is true if the number of trees is magical, i.e. 127 or 129. Okay, so now when users come across documentation, they will know that this is here. Cool, so that's an important part that we need. And then the last thing we need to do is we need to test it. So let's go to our random forest tests, and I'm going to add a new one to the bottom of the file. Magical number of trees test is what I'll call it, and it'll be in the random forest test suite. Okay, so I'm going to borrow from another test. Let's just go ahead, we'll load the iris data set, that's fine. Because I don't actually care what data set we load. All we want to do is test that we get back true when the number of trees is 127 or 129, and get back false otherwise. So I'm going to create 3 random forests, RF1, RF2, and RF3. So I'll train the first one on the data set, and there are 3 classes in the iris data set, and then the next parameter is the number of trees. So let's do 125. Second will be trained on 127 trees, and then the third will be trained on 129 trees. So once that's trained, all I need to do is test is number of trees magical. Should be false for the first one, and then it should be true for the second two. Okay, and so that is our unit test. So with all of that done, we can go ahead and build. Oh, and the build has failed because I've done something wrong here. No declaration matches. Oh, yes, this is what happens when you copy paste here, because this does not have these template parameters. So, great demonstration of why copy paste is bad. Now that that's fixed, let's try this again. Okay, now that the build is finished, we can go back to our terminal, and we can run the whole random forest test suite. Random forest test. And everything passed. So if we wanted, we could even run our magical num trees test directly. Magical num trees test. Okay, cool. So now we're ready to go ahead and contribute this back to the mlpack repository via a pull request. Okay, so now we can use VSCode's integration with Git to do this. So you can see we've changed 4 files: the markdown documentation, and then the random forest file that defines class, the implementation, and then the test. So instead of just committing directly, let's create a new branch. And I'm going to call this branch magical num trees. Hit enter. And now we're on a branch. So now I can commit after I write a message, and the message will be add is number of trees magical and tests and documentation. Now I'll hit commit. And now I can hit publish branch. So now if that branch got pushed to my GitHub fork of the mlpack repository, I could then go to GitHub and open a pull request. And so I could do that, and I could type in a description of why I added this function, what it does, and then it would get reviewed and merged. Okay, so I hope that this has been a helpful discussion of how you can use mlpack with VSCode to develop and contribute to the library. As always, if you have any questions or anything like that, you can go to mlpack's matrix channel or to the documentation or open an issue on GitHub.